Okay, multiple allele practice activity question 1. This is can be found on page 17. You also have a answer key available for all of those. So if you just click the link that says click here for answer key, obviously you're going to get the answer key for all of these. But let's just practice one of these questions together. So let's get right to the question. It says indicate the genotype of a cross between a heterozygous wild-type red fly with a honey allele, and so that's one of the parents. So let's underline the parents with a honey allele and, sorry, that's still the same parent. Okay, there's the other parent, and a heterozygous apricot fly with a white allele. Now we know the legend for this. Let's just do that. That's always step 1, but we've done this in a previous video. So we know if it has an E1 with anything else, it is going to be red. If it's an E2 with anything else, but it can't be a 1, that's going to be an apricot. And a E3 with something else, can't be a 2 or 1 though. It has to be either itself, E3, E3, or something recessive to that. That's going to be honey. And then the only way that you can have white is if both your alleles are recessive, E4s. And those numbers, of course, are superscript numbers that are used to show the hierarchy. So this would be white. Okay, so really quickly, it says a heterozygous red. So if it's red, let's put the genotype here. It has to have at least an E1. And they're telling you what the other allele is. With a honey allele. Honey allele is E3. Okay, so now we have the red parent. The other one is a heterozygous apricot. So apricot, take a look at our legend, must have at least an E2. And then they're telling you what the other allele is. It's an E4. Okay, so again, multiple alleles, you have to use a letter with a superscript. Sometimes that superscript is going to be numbers, like it is in this case with the eye color. Sometimes it's going to be letters. But those are called superscripts. Super like Superman, flies on top. The other little ones that you use in chemistry are called subscripts, right? So with those superscripts, now that we know the genotypes of these parents, we are now able to go to step 3. And step 3 is a Punnett square. So you may see questions where they don't give you the genotypes for the parents, and you're going to solve it the same way. Go look at some recessive offspring to fill that in. But in this case, we know it. We don't know male or female. So just arbitrarily, we're going to put this genotype up here, isolate them into gametes, take the other parent, isolate them into gametes, and we're going to fill them in. So even though it's multiple alleles, a particular phenotype still only is represented by 2 alleles, right? So now, same thing. When we're filling this in, you must show your dominant allele first. So we're going to go E1, E2. We're again simulating fertilization. Go look at our legend. That's why we bothered to do a legend, so we can interpret it. And it says as long as there's an E1 and anything else, it has to be a red fruit fly. Okay, keep filling this in. E2, always put the dominant first. E3, take a look at our legend. Anything with the 2, doesn't matter what the other allele is, it's going to be an apricot. E1, E4, as long as there's a 1, has to be a red. And E3 and E4, as long as there's a 3 and something recessive to that, is going to be a honey. So this particular question, it wanted you to know the genotypes. Let's just put the phenotypic ratio, even though the question's not asking it. Most questions will. So we count up the boxes. We see that we have 2 that are red. And then we take a look. We have 1 honey. Or let's use apricot first. I like to put them in order of dominance. And then 1 honey. Now, you don't need to do this in this case, but if you do have ratios, phenotypic ratios, you must reduce phenotypic ratios. Okay, so all I mean by that is if you had, let's say, a 2 to 2, that would reduce to a 1 and 1. Okay, but in this case, you can't reduce all of them. 1 is as far as you can go. So we have 2, 1, 1. 2 red, 1 apricot, 1 honey. Okay, thanks guys.